So we'll import a new data set, the miles per gallon data set from the ggplot2 package. And the first thing we should do anytime we import a new data set is look at the data. So we'll do that using the view command in RStudio, and here we have our data set. We see its information about cars, we have some information on what year they were made, some information on the engines, and in particular some information on fuel efficiency. So we could do things like, say, sort city fuel efficiency, and we see here some low fuel efficiency, and that corresponds to some larger trucks, which sort of makes sense. And if we sort to higher fuel efficiencies, we see some smaller cars. We already understand a little bit about this data, but one question we should ask ourselves is, where did this data come from? What is this data? So to do that, we should pull up the documentation. So we see that this is data from the EPA from 1999 to 2008 for 38 particular models of cars. And those were models that had a new release every year between 1999 and 2008. We should note that this may not be a representative sample of all possible cars from that time, but it's specific to these 38 models. We'll want to summarize some of this data. One of the variables we're going to look at is the city miles per gallon. To summarize a numeric variable, which city miles per gallon here is, we'll want to know where is most of the data, so where is it centered, and how spread out is it. So a number of the things that we're about to look at are statistics, and we'll use them now for simple summaries of data, but we'll discuss them in much greater detail later. So first, some measures of center. We would have the mean and the median. So the mean is often referred to also as the average, so we could sort of compute this ourselves. We could say, well, we want the sum of the data divided by the length of the data, so what we would commonly refer to as average, and we see that that is the mean. The median is a point that splits the data in two. So 50% of the data is below this point and 50% of the data is above this point. We can try to do this ourselves. So first we need to sort the data. And now we need to find the midpoint of the sorted data. So this is a vector. So we'll take this vector and we will subset it to be, let's see, this would be the last element. That's 35. So we want halfway. So we see that 17 is indeed the median. We see that the mean and median here are fairly close together. So they're both giving us an idea of where this city fuel efficiency is centered. And we'll come back to the fact that these are very close together right now. We can move on to spread, and there are a number of ways to measure this. We could look at the variance, the standard deviation, the range, which is actually two numbers, the minimum and the maximum, and the IQR. So let's further talk about standard deviation and IQR. So the standard deviation, the name sort of tells us what's going on. It gives us more or less the average deviation. So first we should talk about a deviation, which is how far away each data point is from its mean. So these are the deviations here. So this is how far away each data point was from the mean. And sort of we want to average these things, but let's note that if we were to average these, I was going to do sum, let's do mean. We see that it's a very small number, which is essentially 0. So we need to average something else that's not the actual deviations, but instead the square deviations. So if I take the average of these, what do we have here? We have 18.03, and I'm going to do one more thing, which is take a square root, which is because I squared things here, now I'm in units squared, so this is miles per gallon squared. I would like a measure of spread that is in units miles per gallon, so I take a square root, and I have this number here, which let's compare to the standard deviation. So it's very close, but it's slightly different. And this is a detail that we'll talk about much later, but just know that the standard deviation is very close to the average of the squared deviations. And then, again, taking a square root to put it back into, this tells us an average deviation in terms of city miles per gallon, not city miles per gallon squared, which is actually what the variance does, because the variance is just the standard deviation squared. We also saw that the IQR was 5, but we don't know what that is yet. To understand what that is, we should look at what we call the summary of the data. So the summary function in R will come up quite a lot. It has many uses depending on what we give it as an argument here. Let's find out what happens when we give it a single vector of numeric values. We see a number of things here. So this sort of summarizes the data. We have the minimum and the maximum, which is the range that we saw before. We have the median and the mean, which were the measures of center that we saw before. We also have the first quartile and the third quartile. So these are similar to a median. So if the median says 50% of the data is below this number and 50% is above, the first quartile for quarter, 25% of the data is below, 75% is above. The third quartile, 75% is below, 25% is above. So the IQR, the interquartile range, we see that that is the third quartile minus the first quartile for 5 here. So that tells us where the middle 50% of the data is. So we mentioned that the mean and the median were rather similar here. So I want to see what happens if magically we make one of these cars get 500 miles per gallon in the city. Unlikely, but let's see what happens if we do that to our data here. So let's see what happens to the mean and median. We'll actually reproduce a summary here. So the median stayed the same. It was not affected by this crazy fuel efficient car here, but the mean increased. Because of this, we say that median is a robust statistic, whereas mean is not. So mean was affected by this sort of massive outlier, whereas the median was not. This is why we use median for things like average salary, average home value. So a few high earners or a few very expensive homes don't sort of throw off our measure of center here. I'd also note that before the standard deviation was roughly 4.2. Now if we look at the standard deviation, it is much larger, whereas the IQR did not change. So we'd say that IQR is robust, whereas the standard deviation is not. That's a number of numeric summaries for numeric variables. We could also come up with numeric summaries for categorical variables. So for example, here we have the drivetrain variable, which tells us if the car was front-wheel drive, four-wheel drive, or I believe there are some rear-wheel drive cars in here. Yeah, here's one. We can use the table function to quickly sort of summarize this data. So there were 103 four-wheel drive cars, 106 front-wheel drive cars, and 25 rear-wheel drive cars. This is a simple count. If we divide by the size of this data set, we could get proportions of those three drivetrains. I'd also return here the different classes of cars, and I would note that we have a lot of pickups and a lot of SUVs, and I think that sort of explains the not so great fuel efficiency that we've been seeing in this data set.